Hey, so listen, I've made no secret of the fact that I personally believe that nuclear power, especially thorium breeder power, is the long term solution to moving away from carbon energy sources, fossil fuels. But wind energy really is a viable option and really the only other viable option. So let's just go ahead and take a look at wind energy. So wind energy is the simplest you can possibly get. Basically, I have a turbine, a blade. Okay, the wind is going to blow on it, so I'm just basically taking the kinetic energy of the wind as it blows past it, and I'm using it to turn a generator. I'm spinning a coil of wire inside a magnetic field, and I'm making electricity. It could not be simpler. It is really, it's like the easiest technology you can possibly imagine, other than you've got to find a way of making these blades light enough and strong enough to withstand the wind. You've got to make sure that the nacelle is able to rotate to face the wind. You might want to have the blades be able to change their angle. So, I mean, it's a little bit more complex than that, but basically, it's a pretty straightforward technology that's been used. I mean, people have been using windmills for centuries to pump water. So, the typical windmill wind turbine, we like to call them, is about this size here. All right, so they top off at around 140 some meters high. They generate about 2 megawatts of power, but that's basically what they can produce. I mean, obviously, if the wind's not blowing, they produce zero, but they don't produce more than that. And they cost about $2 million to build. So each one costs about $2 million, and it can theoretically produce 2 megawatts of power. So let's think about this then. Your typical coal station, and remember, I cannot say enough bad things about coal. We really need to stop using it today. But here's the thing: people go, "Well, we use coal because it's cheaper." Well, is it really? Because it costs about $2 billion to build a coal-fired power plant, and that's not even taking into account the fact that you got to buy coal and there's a lot of operating expenses, and it generates 600 megawatts of power. Okay, so if we say, well, a typical power station is 600 megawatts, how many windmills would that be? Well, that means I need 300 wind turbines since they each produce 2 megawatts optimally. So, and if they cost 2 million each, that's $600 million as opposed to $2 billion. Yeah, that's a lot cheaper. That's almost 4 times cheaper. So wind and you don't have to pay. You don't have to buy coal, right? There's no real operating expenses. There's some maintenance, but really not much in the way of operating expenses. So that's a big win there, right? So why don't we go there? And let's just talk about some of the benefits here. Okay, so first of all, it is a completely renewable resource. The wind is always going to blow, right? There's no question about that. So as long as the sun is shining, there'll be temperature differences on the atmosphere making convection happen. So there's always going to be wind. There's no carbon produced by windmills as they operate. There's no other hazardous waste produced. There's very little negatives associated with this. Theoretically, we could scale it up to meet societal needs. And I'll ask you to do this in your activity section. You'll see it takes a lot of windmills to do it, guys. It could be done, but you're going to live in a world full of windmills, but we could do it. And also, it can be done quickly, and you can put it in places like developing countries that don't have an electric grid really that's very functional at this point, and you could basically get them electrified without ever going towards fossil fuels, which would be a really good thing. So there's a lot of benefits here, right? So what's stopping us? Well, let's just think. Okay, one of the things that a lot of people point to, and I won't name names, but people point out, well, it kills birds, it kills bats, and that is true. It totally does. Okay, but if you ask me, if I had to kill a lot of birds to save the planet from the destruction that's happening because of coal, I'd do it. But anyway, here you go. Here's the deal. If you look at these things when they're operating, they don't seem to move very quickly, right? So they rotate maybe 5 to 20 times a minute. So the rotational velocity, I mean, how many rotations, how many degrees per second, it's not that great, right? But the blades are really long. So if you look at the tip of the blades, even though the blade itself is not rotating that many times a minute, the far edge of those blades is going like 160 kilometers an hour. And that's certainly faster than most birds are able to calculate and deal with. So it does kill a lot of birds. So, accounts vary, but basically in the United States, wind energy right now accounts for less than 7% of our energy, electrical energy, and it kills about 500,000 birds a year, and probably not quite, but almost the similar number of bats. Okay, that is a problem. Okay, I'm not going to deny that. But it's a problem that can be mitigated. So you should know what some mitigation suggestions are. So one mitigation is, all right, Don't put them in the places where there's a large bird migration pattern. So it's very easy to study bird migration patterns. They're already known. Don't put them in migration corridors. Okay, or if you do, then shut them down, power them down when you are in migration season. So birds have fairly predictable migration seasons. I mean, it does alter a little bit with global warming, but it can be monitored, and that's one solution. Another one is you can use ultrasonic sounds to scare away bats because bats are nocturnal. So why are they coming to these blades? Well, the reason they're coming to these blades is we paint the blades white for cosmetic reasons. They look nice to us that way, right? But that means it reflects light. It attracts insects, and many bat species are insectivores. So they're drawn towards the presence of insects, which are drawn towards the light-colored blades that are reflecting moonlight. And so what we could do is we could simply paint the blades a color that's not going to reflect light, which means we're going to look at them, and instead of being this pretty white, they might be black or brown or some other color that is more disruptive to the eye. I suppose maybe we could paint them blue so they look like the sky. I don't know. Okay. Another thing we do is we just not use them at all if they're not generating much power. So you could shut them down when the wind speeds are too low to be generating electricity, and that way you would save some birds and bats. Okay. Another problem that we have with these, and I'm going from smaller to larger here, okay, is that they're noisy and they're ugly, and that makes people not want to have them. Okay, so the truth is, even though coal is so disastrous to the environment, you don't notice it, so you don't mind it. But if I start putting windmills up, and everywhere you look, you see windmills, they're noisy, so you don't like the sound of it, and they're ugly. So if you went to some beautiful place like in Europe, oh, I want to see this castle on the hill, and behind it, there's all these windmills. Like this happened to me on Jeju. Like I climbed the top of this Orem, this volcanic parasitic cone, and it's when I got to the top. Oh man, there's all these windmills in my face. It kind of ruined the moment for me. So yeah, they are aesthetically unpleasing. Uh, and we just don't like our natural view disturbed. So one solution to this is you could put them in places that people aren't going for beautiful views, right? So avoid disrupting beautiful viewpoints and put them in places like farmland. I mean, have you ever driven through the middle of the United States? It's just like an infinite sea of corn and wheat. If there's nothing pretty to see, why not put windmills up there? In fact, they might actually look pretty there compared to what you have otherwise. And also that way farmers could have the added benefit of leasing out the land and getting some added money out of it. So, and also too, farmland has no trees to slow down the wind, so it blows a little bit faster. So that's one really good idea here. Is just to move them to farmland. But the solution that has the most promise and the most focus right now is moving them offshore to make offshore wind farms. And there's a number of benefits associated with this, and there's also some problems. But let's just look at this because this is really where the future of wind seems to be going right now. So here's the deal. So if you move offshore, so it is definitely way more expensive to build them offshore and to maintain them offshore than it is on land. Okay, but they're not. If you put them offshore, people don't have to see them. They don't have to hear them. So you avoid that objection, which can be a very large objection. Um, Also keep in mind there's a lot of surface out there, right? So there's an awful lot of near shore ocean surface that we could access more than we need to power the world, really. And because there's no trees and buildings and other things to block the flow of wind, it blows more consistently. And also remember, we talked earlier in the year, we talked about what causes convection, and you get that sea land temperature difference. There's almost always a temperature difference between the land and the ocean, so there's almost always wind. So the wind blows very consistently there. So you basically get about 3 times more energy per day or per month out of a wind turbine that's placed in the ocean than if it's placed on land. So there's a lot of reasons to do it. Right? And in fact, Korea is committed to doing it, right? So Korea is building wind farms offshore. They're building it off the coast of Mokpo right now. It's already been the money's already been earmarked. They think it's going to be completed by 2030, and it'll be the world's largest wind farm. So way to go, Korea, right? Way to pave the way forward for green energy, right? So, but keep in mind, it's going to produce about 8.2 gigawatts, all right, whereas the country is using about 127. So it's still, you look at it, it's like not that much of our energy. I don't know, what is that like 6% of our energy, 7% of our energy. So it's just not that much. But still, it's something. It's a step in the right direction. Okay, but my message to you guys is We don't need half steps. We need to go forward with leaps and bounds. But now let me tell you what the big trouble with it is. Apart from the fact you need a lot of windmills, and I mean a lot of windmills to make this work, it can be done. And it probably is the best long-term solution for the world's energy. But here's the biggest problem. And the biggest problem, and you need to know this, is the inconsistency in the wind. And it is a huge problem with both wind and solar, as we'll see. So if you look, and I just sort of, I make this sort of an ideal version. So if you look at how much power is used in a society on a given day. So we're starting at midnight, most people are asleep, so we're not using much power. As people wake up, they go into work, they use a lot of power, they go home, they have dinner, they start settling down, they use less power. So you get this very predictable pattern in energy demand, and a power grid has to match that. Remember, we're not storing energy on the grid. We're just putting energy on it. It's getting used right away. Well, the problem is the wind has no reason to mimic this pattern. So the wind blows when it blows and doesn't when it doesn't. So we might get big, huge spikes. It's blowing really hard and it's not blowing at all. Well, we need consistent power. Yeah, we're getting power in the off hours, but not in the peak hours. Well, that's a problem. That's a huge problem. Okay, that's it seems like an insurmountable problem if you want to do this. And again, solar's going to have the same problem because of clouds and seasons and things like that. Now, there are two solutions here. One is to use what we call a smart grid. So a smart grid, and this is being used in the United States, especially with people who have solar power on their roofs. The idea is I'm still using coal and nuclear and hydro to make most of my electricity, but then when people have solar, people have wind, we're putting it on there, and I just have to have a grid that can monitor how much of this energy is being put onto the grid, and then communicating with these other power generators so they can produce less at that time. And you had to do it in real time. It is technologically feasible. In fact, it is right now. It doesn't really matter much because there's so little of that happening. But if we were to scale up, we'd have to do it more. But here's the drawback. For this to work, the majority of your energy still has to be coming from these sources here. You've got to either be mostly nuclear or mostly coal if you're going to achieve this. Basically you can conserve these by adding this to the mix, but because of the variability in this, you can't make this the majority of your power. It just wouldn't work, right? So I mean, yeah, that extends your resources of coal and nuclear, but it doesn't get you away from it. It doesn't make you a non-carbon or a non-nuclear energy grid. But there is one exciting idea I want to share with you, and I don't think this even comes up on the. It's so new; it's not even on the AP test. But I want you to know about it because those of you who are passionate about trying to find a solution to the world's energy dilemma, but are also, unlike me, very anti-nuclear. Here's what you should be advocating. Okay, so the deal is, if we're going to completely rely on wind and solar as renewable energies, we have to deal with that variability problem. And so what people have come up with is what they call pumped hydro storage. It's such a cool and yet simple idea. So it basically goes like this: when the wind is blowing or the sun is shining, and I'm generating a lot of wind, a lot of solar energy, I use that energy instead of putting it on the grid. I just use it to pump water uphill to an uphill reservoir. All right. And then when the wind isn't blowing, or when I have power demand, I have water coming down the hill, just like in a hydroelectric dam, turning a turbine just like it does in a dam to a lower reservoir. And so it's brilliant. So because of this, I totally avoid the whole variability problem. Now, the drawback is there's going to be a little bit of inefficiency associated with this because you are going to lose some energy to friction in doing this, but still, it does allow you to have continuous power output with just using entirely green energies and using entirely wind and solar. So it completely smooths out those spikes because whenever the wind is blowing, whenever the sun is shining, I'm just using it to pump water uphill. And power demand by society is just water flowing down the hill from the same reservoir. It's really a cool idea, don't you think? And they've mapped out there are hundreds of thousands of places around the world where you have the ability to put these in. Now they're not always near, like if we make offshore wind farms, we're going to lose some energy bringing that electricity in to a place where you could do this, but also could inform us as to where good places to put in our wind farms are. Okay, thanks for watching the screencast.